All right, so we have just arrived at the diamond factory. First feelings?
Finally.
Yeah.
Long wait.
We're very excited.
Super excited.
I remember when I was here for the first time, and it's a pretty good feeling.
Welcome to Diamond Canada.
Oh, thank you, Dirk.
Identical buildings to this one in Downsview in Toronto, just a couple hours away. And we were known for building mosquito bomber fuselages in this facility and the fly sander that I showed you earlier. This was also a large repair facility. So the Allied training program that was going on for pilots, navigators, bombardiers was in full swing here in Southwest Ontario. There were scattered bases throughout the region. And if they ever bent or broke an airplane, they would bring it back here for repair. At the height of the war, there was about 1,500 people a day working at this building. Currently, we've got about 500 diamond employees here on a daily basis.
Yeah, look at that.
So yeah, just a few more. I noticed you were looking at some of these other photos here on the wall. They flew back in the day. And of course, you saw this photo as well with mosquito bomber fuselages rolling down the factory floor. And again, what's really interesting is they were building fuselages the same way we're building fuselages, with the left hand and the right hand mold set. Except instead of laying in glass and cloth fiber, wetted down with the resin, they were using steamed Sitka and balsa plywoods. Thin layers of veneer glued together. They would steam it, force it into the molds. They would then kiln dry them, and then they would epoxy glue the two halves together to get the final finished product. And in my research, I also found that they had pioneered the use of some pretty high-tech epoxy glues at the time that used RF radio frequency energy to help dry the epoxy glues when they made the two halves together. We've also got some newspaper archives in our collection as well, and there's an article that talks about the mosquito bombers that were built at this factory that bombed the Messerschmitt factory in Wiener Neustadt, which is where diamond originated from. And almost 70 years later, Christian comes here and buys the building, built the bombers that bombed his hometown airport.
It's a small world.
Yeah, it is a very small world.
Full circle.
Indeed. And then if we duck in, was a clipped wing version of this airplane here, using tricycle gear like this one, with an 81 horsepower Rotax engine. And then those were quite popular in the early 90s, which drove him to finding a Canadian location or a North American location to start sales into the US and the Canadian market, which is how he found this building. So we moved in here in 92. Took us about a year to clean the place up, get it ready for production in 93. I joined the team here in 95 in September. And at that time, we were building the DA50 version. So again, a Rotax powered airplane. But then in 97, we had developed and certified the DA20C1 using a Continental IO240B. So it went from 81 horsepower to 125 horses. So a significant improvement. We also improved the panel layout, the ergonomics, the seats. There was quite a bit of improvement with that model. And then in 2001, we introduced the DA40 here, the Lycoming version in North America, and Austria had the TDI version, which was using a diesel engine. And then in 2004 was the first DA42, and that's the one that I mentioned where we were the first ones to certify the G1000 avionics system in the general aviation airplane. Mm-hmm. And then, of course, in 2015, we introduced the DA62, and then a few years later, your DA50. And then this aircraft here is one of our MPPs, which stands for the Multi-Purpose Platform, and it's an ISR platform, so intelligence, surveillance, and reconnaissance. And we have a separate division in Austria that builds about 20 to 25 of these every year. There's a few interesting features. They do a lot of beefing up of the composites in the wings and the nacelle area, and of course in the nose, where they generally house an electro-optical gyro-stabilized camera, infrared camera as well. And then the latest versions even have a large Rigel camera that comes out of the back that drops down through a hole in the bottom that can do large aerial surveys and photography. We've got a maritime patrol version, a border patrol version, and then there's even a version that for search and rescue. And then also some versions that we built that are built for mineral exploration. So there are magnetometers that come off of a little boom off the wingtips, and they're looking for magnetic anomalies. There's a customer in Toronto that has 4 of them, and he flies them in Northern Ontario during the summer months. Anywhere from about 250 to 450 feet AGL. And they just do grid lines back and forth.
That'd be cool to see one of those up close. I don't think I have.
It looks like little tiny tuna tanks, like on the end.
They've got all the toys.
So that's basically like just a quick summary of the Diamond lineup and how they've come about over the years. Most of these aircraft were developed at our Austrian facility, with the exception of the DA20. And then also we had the D-Jet program here in the 2000s, in the early 2000s, that we were also running out of here. However, the financial crisis in 2008, and then our engine manufacturer Teeler went bankrupt just shortly thereafter, which left us in the lurch. We were actually doing DA42 final assembly here, and we ended up with a bunch of work in progress on the line, and then no engines available. So
2008 was a bad year for everyone.
It was a bad year, and the funny thing, it wasn't funny, but the owner of Teeler was actually here at the factory 2 weeks prior to them going bankrupt, so nobody had an inkling of what was about to happen. Wow. And at that point, Christian set out to build his own engine, which is how the Austral engine came about. So with the demise of Teeler, and with the financial crisis and the total downturn in the aviation economy, the decision was made to finish that program and then move the funds into engine development. And in this case, in this airplane here, they've got an interesting exhaust system that wraps around the top, so it channels all the hot exhaust gases over the top of the wing, so it makes the airplane much more quieter.
I was going to ask what that was.
And it also reduces the IR signature from the ground as well, because most of the hot gases are on top of the wing, so
that's cool.
It remains a little more stealthy that way.
Do all of them have this drop down?
Originally, when this whole program started, believe it or not, we started it with this airplane. We hung a gyro-stabilized West Cam off the port wing.
Really? Then, the 20?
Yeah, and then on the
so cool.
on the HK36, the motor glider. Yeah, it wasn't a 20, it was the long wing
version
of
okay, yeah.
With the live video downlink.
That's cool.
Of course, when the 42 came about, it just made sense to move that program onto that airframe, because it gave us so much more payload capability and endurance as well. And performance otherwise. And then when the 62 came about, it again made sense to move it into this platform. And yes, these drop-down stab tips just give it a little more longitudinal stability, especially when you've got all these things sticking out on the front and the back.
But does a normal 62 have that?
No.
Oh, okay.
That's what I was thinking. I was like, it's usually not on, the regular ones.
Like I said, we build about 25 of these every year, and we've got them scattered throughout the world. They're being used by just about everybody. All right.
Yeah, it's awesome.
Neat greenhouse style roof design that we've got. Lets in a lot of natural light in the winter. We're guessing this was taken late 1940s, early 1950s, judging by the automobiles in the parking lot. The access to the runway used to go up this way. You can still see the remnants here at this taxiway behind the north hangar. This is now a golf course, a small 9-hole golf course back in here. And now the taxiway makes a right turn like this, and then another left turn and goes through the Enchanted Forest. This set of woods has really grown and evolved over the years. The north hangar was renovated many years ago. Our maintenance shop is located in there, our maintenance facility, and we just recently emptied the east hangar, and we're about to renovate it. And eventually we'll move our shipping and receiving area and our stores area, which is located here in the back portion of the factory, into that building, and then it'll free up more floor space for final assembly. since we're building, four or five models now. We're building the DA20s here, both models of the DA40, the DA62, and the DA50. We're also doing assembly on as well. The DA42 is the only airplane in those MPPs that are built exclusively in Austria. This little feature here is where they used to offload the munitions for any aircraft that came in for repair. These are 5-6 foot thick concrete reinforced walls. Wow. And if any of that stuff ever cooked off, it was designed to channel the blast upwards rather than into the factory. These chimneys are no longer there, but this is now our south cafeteria. And in the back portion here, we've actually stored some of our more volatile compounds as well. And then, of course, these two front buildings are now gone, and the parking lot is paved all the way through. But yeah, and then that brings us into the factory floor.
Yay!
So we see a lot of parts here on the shelves. These are mostly DA62 components. And then as we move down, you'll see more of these light translucent gray parts. So these are. This is your typical fiberglass part, the glass cloth. It's translucent. And then if you move into your airplane is built almost, I would say 98% is carbon fiber, whereas the DA20 and the DA40 is built probably 95% glass cloth with the remaining 5% carbon fiber to reinforce it in certain areas.
Pretty strong, yeah?
We also build a lot of the metal components, the few metal components that we do have in the airplane. So, for example, these instrument panels here are built in we've got a full metal shop with a large water jet cutter that uses a 36,000 PSI water jet mixed with like a sandy aggregate material to help cut all these holes. It's all CNC controlled. And then we'll continue to build up the panel with the back of the screen. Reinforcements, then it'll go to the paint shop, get a coat of paint, and then it sits here waiting for our avionics shop to pull it to build the instrument panels. And this shop not only produces panels and wiring harnesses for our production here in Canada, but also in Austria as well. So we ship a lot of this stuff overseas.
It's really cool looking.
The production in there.
Yeah.
So we build all of that, including some examples here on the shelf. So wiring, bus assemblies, cable assemblies, the joysticks, the LRU boxes, the line replaceable unit boxes for your G1000 system. That box is also manufactured in our men's shop as well. And then you'll notice when we go into the avionics shop, you'll see a lot of the wiring harness tooling boards. And here's an example of the wiring harness tooling board used to build the harness bundles for the DA42 that goes into the wing of the DA42. So this is wired on the underside as well. And on the far end, there are 4 or 5 large serial cable connectors. And do you see that red cart down there with the silver top? That's the testing machine that we roll up to one of these boards. And
Just touching parts over here. Dirk says to touch it.
How lightweight it is.
Yeah, look at that. That is very light.
And then from there, that harness either goes to the front of the room where they build up the instrument panels, or it might go into the aircraft, into the belly of the aircraft itself, or into a horizontal stab prior to them closing it up in composite operations. So if we come in here, we'll see a few different examples of instrument panels in various stages of completion. They start pretty early in here, around 6 a.m., so most of them are gone, although there is an afternoon shift as well. So normally there's about a half a dozen folks that are sitting up here, and it takes them about 40 hours to build up one of these panels with the harnesses that are being supplied from the tables that are being built farther down the room.
That is a lot.
I'd like to learn how to do that.
Here's some finished examples here. So this is what your DA50 panel looks like when it's completed. And then this would be a DA40 panel. This is also a DA62 panel. 62 panels.
Yeah, it looks familiar. Yeah, look at that.
These are both DA62 panels, but yours is almost an identical copy. And then we've got full testing equipment. So when these are completed, they'll roll it up to this machine. They can again test for full functionality. And then if we walk down the length of the road here, you'll probably see some different wiring harnesses in different states in assembly. So
That could be kind of cool.
the whole process first starts on the far end where we've got the raw bundles of wire. The wire comes pre-laser etched with identification codes, so it makes it easier to do maintenance down the road if you need to try to isolate a wire in the system. So they'll start with smaller 5-10 strands of wires with lug connectors connected. They'll test for continuity when they make when they attach the lugs, and then they generally put them into file boxes like this along with the paperwork, and then they can draw from these boxes to create larger harnesses. These are some of the automated coax connectors, automatic lug machines. Paul Bertorelli from AbWeb did a video a few years back on how we built DA40s.
Yeah.
And he was geeking out on this machine here.
That's cool.
Yeah.
Look at that. Yeah.
It's all
Gotta
electronic.
clean the
and
floors.
You can specify how far back you want it to trim the end of the wire.
Yeah.
Expose the coax.
Is he just sitting here like
yeah. It's got a little arm
That's
that goes
cool.
in, does the cutting job, and then
Yeah.
within seconds it's finished.
Yeah, look at that. I liked your when you guys do the carbon fiber strips over there. That's probably my favorite machine.
But before we go this way, let's just come back this way just a little bit. This will work. Okay. So here's a fiberglass part. You'll notice this dark area. This is what we call sheet stock. And I've got a rack here that has all different shapes and sizes and assortments of various thicknesses of sheet stock. Anywhere where there's a mechanical connection. So for example, where your horizontal stab is bolted to the vertical stab with 4 or 6 large stainless steel bolts, we embed a lot of the sheet stock in there. And this material will really take all the torque and the pressure from those mechanical fasteners without degrading the material itself. So come back to this shelf over here, practically indestructible.
I was about to say, I mean, that's...
Yeah, it will last forever. And of course, this is the glass version, and then the carbon fiber version will look very similar, usually thinner.
So this is in all the carbon planes?
It's in all the carbon parts that require a mechanical fastening at some point. So, for example, right here is that horizontal stab for a DA62 or a DA50. And this is where that sheet stock has been embedded, where the 4 bolts will hold the horizontal stab to the vertical stab. Bend them into the appropriate shapes prior to having them laminated in between layers.
So you'll form every DA50 same
Way here. But here's an example of the foam core. So they'll generally use these grids here. They'll weigh down the foam core. They'll put those grids on top, and then they'll roll it into this oven, and we'll pre-shrink the foam core for several hours in this autoclave. And then from there, they'll bring it back into Compops. They'll cut it into various shapes and sizes, chamfer the edges if need be, and then place them into these forms that we have here. So these ones in particular are for the center wing section of the DA62. So this is one of the nacelles, like just after the engine firewall. There'll be several pieces of foam core placed in here. They'll run a bead of sticky tape around the outer edge, and then a layer of breather cloth, and then a layer of plastic to make it airtight. And then we'll wheel it into the oven, attach the vacuum hoses, and then let the oven and the vacuum pressure do its work. So, for example, in the DA40 fuselage, we use several long strips of foam core, and I can show you once we get into Compops where they're positioned. But these molds will help shape them and get the correct curve to the actual foam core. And then over here is where we fit DA62 wings. So here's a center wing section, and of course your left and your right wing. And at this station, what they'll do is they'll fit the wings in place, and then they use a, let's see if we can put it here, but they use like a surveyor's transit to shoot bearings. So they haven't bonded the brass bushings in yet into these spars.
You see the twin spars though?
Yeah, the finished ones will have a brass bushing here, and then the steel pins will go through the brass bushings and hold it in place. But at this station, oh, here's another example of the foam core, the sheet stock, front and back. This is where your A and your B pins are located, and they fit neatly into these A and B bushings. So when you fit the wings into place, or once they get this all bonded in and ready to mount to the center wing section, they'll set the dihedral, they'll set the sweep of the wing, and then they'll also set the angle of incidence of the wing, and they'll dial it in with these two bolts. And once that's done, whenever they service your aircraft, they'll just undo the access panels underneath, pull the steel pins out, disconnect the flap and aileron controls, the fuel lines, and the electrical, then the wing comes right off. It takes maybe 20 minutes to pull a wing. And as you mentioned, if you were ever to damage a wing bad enough that
they
you
thought about everything.
It, you could just order a new wing. They would reset these angles, and then again, you're good to go. It's very easy to pull a wing on and off whenever you need to service the fuel tanks or do an annual or whatever the reason might be. And then, while I've got this here in front of me, these are the high-density fold blocks. This is part of our passive safety system. So all of our seat hands sit on top of these high-density foam blocks, and in the event of a crash, they'll absorb a lot of those impact forces rather than transmit it through the seat and into your spine. Our seats are also slightly reclined as well. The reason for that is to prevent you from submarining under the lap belt in the event that you come to a really sudden stop, and then you're not going to break your legs in an instrument panel. So that will prevent a seat rail from sliding back as the airplane ages. Just one of the many passive safety features that we build into the airplanes. And of course, one of the biggest safety features are these twin spar design in the wing. So the fuel tank, you'll notice actually this one
it's not coming off.
Doesn't have a fuel tank in it, but you'll see that cavity goes right down to the end of the wing. And I can show you some examples of the fuel tanks when we get them to the far end. And then behind you here is where we build up the wings, the horizontal stabs, rudders, elevators, flight control surfaces. They're all weighed and balanced here. There's some DA40 wings here for serial number 365 that are currently being worked on.
Oh, I know.
Oh yeah, I see it.
Fuel tank?
So here's an example of your fuel tanks.
So this is where the
tank
inspection points are underneath the wing, right above it.
Correct.
Right below the
Correct. And then this would be the outboard end. This is where you're fueling the tank from. So that would be the inboard end. And of course, it's designed to flex with the wing in flight. Having sandbags into the bottom of it, that slowly starts to bend the wing up to supposedly the breaking point. The jig failed at 29 Gs. The whole jig just came apart. So we call it a fail-safe wing because they didn't need to test it beyond that point.
They couldn't find the limit.
29's a lot.
20. It's a lot more than your body.
Yeah, that's true.
Yeah.
The fuselage in those.
You're developing an electric.
What would the range be?
Oh, diamond.
Well, it's going to have
So
about
cool.
an hour and a half of endurance initially. So it'll be used as a circuit trainer in conjunction with a larger Jet A fleet. Customers that are using DA50 RGs or the Lycoming version for that matter.
So cool.
So you can do an hour of pattern work, come back, plug the airplane in, change the crews out, give them about half an hour or so, and you can charge that aircraft back up to 90% plus within one short amount of time, and then continue to do more pattern work training. And then, of course, as battery technology improves and gets better, the aircraft will have a longer range and endurance, and then might eventually be able to use it in cross countries or other air work outside in the practice area. So this is where the two lines come up to the machine. Normally there's a There's a dispensing head that's mounted in here. The vertical tube has a helical structure in it that mixes the two liquids together. And then the operator can select the material that he wants to dispense. He can also select the resin to hardware ratio mix. So the four main components. You've got your carbon. This one is now laying on its side, so normally it will be sitting vertical. You've got your carbon fiber caps, top and bottom. You've got the center piece, which is just a piece of foam core, a layer of glass on either side. And then you've got the root ends, which are considerably heavier and bulkier. This one here is for a DA50 or a DA62. You can see just how much carbon fiber is used here and how thick this material is. And this is a clamshell, so there'll be another corresponding piece that fits inside of this. And we'll use paste to bond the two halves together. These have been recently bonded for DA40s. This paste, the white material here, is just a bucket that comes of the resin that comes off that machine, and then we take it to the back room where we've got a large industrial blender, and we mix in milled cotton fibers, almost like ground up t-shirts, to help create a thick paste-like consistency. And that's what we use to bond parts into fuselages, wings, or in this case, to bond the two clamshells together.
Are all the spars combined in all planes?
Yes, the only difference being would be that on the DA50 and the 62, the root end, the thickest part of it, is all carbon on your aircraft, whereas in the DA40, it's that lighter drainage.
Here, I might hand this to you so I can hold it.
Like this set right here. So again, this is more of that sheet stock, the dark areas, and then that light pink area is more of the foam core.
That's
It's
crazy.
adding the foam core helps give it increased torsionality.
Very cool.
It's also in the fuselage, and the wings where we use the foam core, it also helps to fuselage. They've laid all the conduit in place and the metal strapping, which is part of the lightning protection system. There will be this conduit cover, actually, I'm not sure what the actual name of it is, but this will get bonded in over top of all the conduit that you see here and hide it.
Oh,
So that will contain your AC lines, your electrical for the overhead lights, and your oxygen lines.
do you ever need a service in this?
You could,
I guess it all has chase, like channels.
Oh yeah. If you needed to pull, if you needed to somehow replace any of the wiring in there, I'm sure you could fish it through.
Yeah.
Although I don't see that being something that you would necessarily need to replace at any point. No, I think they've done a drive bit on this one.
Okay, so this is what's contained and fastened.
Well, in this case, yes. Yes, this whole center wing section is
the wings bolt on through.
right. Whereas in this case, we've bonded this center wing section into place on the 20s, the 40s, and the 42s. But your airplane is very similar. So you have a spar bridge like this, two large tunnels that run through the center wing section that transfer the loads from the wing to the fuselage in flight. This is a very robust and heavy part of the airplane. And it's probably the strongest one in the airplane. It does.
Assume that's where it's got the most load.
Yeah. Engine cowl.
Wow.
And you'll notice the dark spots here. This is that excess resin that's being squeezed out under vacuum pressure. So it helps to lighten the part itself. Inside of these pressure vessels. So your room stars would have gone through this process at some point as well. And then here's a set of wings, spars that have material added to it. You can see how the cloth sticks up beyond the carbon top. When this goes into the trim shop the next day, those guys have to be super careful when they're trimming this way. If they nick that cap, we've got to throw the whole thing out. Because I mentioned earlier, they're individual rovings that run from tip to tip. So you can't cut into them at any one point, because then we create a weak spot that might eventually develop a crack. And then these are flaps. And we build our flaps the same way that we build our fuselages and our wing skins, with an upper and a lower section. So we will lay down the one mold set, the plastic and the felt material will come away. And so
Composite.
there are samples taken off the machines They're laid, the ones that I've seen are laid into ice cube trays that are wet to set up, and we hang on to those and test those to make sure there isn't some problem with the mixtures, let's say, between the hardware and the resin. There's also a lot of people in this room that have, they're also part of QA. So while they're laying the material into the molds, they're overseeing that they're using the correct number of layers, the correct material in the correct orientation, because typically from layer to layer, there might be movement in the orientation as well. So all of that's monitored throughout the progress as they build up the components. And also likewise, once they come out of this room and then go into the trim shop and get trimmed back, then those parts come back into this area, the parts that need to be bonded into larger assemblies.
Here's the paint shop.
Once your structure comes out of comp ops, it goes into these post-cure ovens right here. They're not running currently. If they were, that yellow light would be spinning. These run at more than double the temperature of that warming room that we were in. And in case the gas or the electrical supply is interrupted, it would be reported, and we would know how much longer it would extend in the post session to make sure that it's 100% clear. And then from there, it'll hit the paint shop, where the first stage is to do a lot of prepping, a lot of body filling. So you'll notice this part, they've done a fair bit of filling and sanding, getting it ready, getting it nice and super smooth for that coated primer and then paint. So here's your G1000 line replaceable unit box, your LRU box. Beside that is the AC unit.
Very nice.
Then you'll see some autopilot servos bolted to the floor back here.
Yeah, there's a G1000.
Seeing all this kind of helps explain the device.
Yeah. There is a lot that goes into this plane. He's clean looking. Oh, look at that smile.
Oh, I love it. I'll take it.
Can you reach it? Not quite.
Yeah, first time.
My steel toe.
How does it feel? Pretty cool.
This is so nice.
He'll take it.
I'll take it. So